Hello, today we will be talking about operations on functions. So we'll be adding, subtracting, multiplying, and dividing functions. We'll also be talking about the domain of those, and we'll be talking about the composition of functions. This information corresponds to information given in the free online textbook from OpenStax. It's the College Algebra textbook, and it corresponds to material from section 3.4. So let's start with this first example. We're going to perform each operation and then state the domain for each in interval notation. So we want to add, subtract, multiply, and divide f and g, those two functions. So let's do the addition first. So it simply says f plus g in the directions. This means f plus g of x, and that's the same as adding the two functions, f of x plus g of x. If we do that, we can see that f of x is equal to x squared plus 2x, because that's what it tells us. So for f of x, we're going to replace that with x squared plus 2x. Okay, and then plus g of x is given by 6 minus x squared. So we're going to replace g of x with 6 minus x squared. And then from there, we're just going to add our like terms. The parentheses here aren't necessary because it's an addition statement. So we have x squared plus 2x plus 6 minus x squared. Notice that the x squared and the negative x squared cancel out. So now we have 2x plus 6. Those are not like terms, so that's as much as we can do. So the sum of f and g are 2x plus 6. That's the sum. So we want to do the same thing for f minus g. All right, so there's f plus g. Oh, and we want to talk about the domain, so let's do that as we go through. The domain, so if we just look at f of x, the domain of f of x, there's no fraction here, there is no square root. So the domain here for f is negative infinity to infinity. There are no restrictions on the domain of f. If we look at g, there are also no fractions here, there are no square roots, so here the domain is also unrestricted, so negative infinity to infinity. If we add these two, it doesn't make any restrictions happen, right? So the domain for the sum is also negative infinity to infinity. Okay. Now let's do the subtraction. So we want to subtract f minus g, which means we'll do f of x minus g of x. F of x is x squared plus 2x minus g of x is 6 minus x squared. Now here the parentheses are necessary because we need to distribute this minus, right? If it's a subtraction sentence, then we need to distribute the negative. So that will give us x squared plus 2x minus 6 plus x squared. Okay, so now we want to combine our like terms. Notice that the x squares do not cancel this time because they're both positive. So it will be 2x squared plus 2x minus 6. There are no like terms here, so this is our difference. Again, on the domain, there are no restrictions to this, so the domain will be negative infinity to infinity. Okay, so we did that one. Now we're looking at the f times g. So the product f times g of x is the same as f of x times g of x. So f of x is x squared plus 2x and g of x is 6 minus x squared. So this is just going to be the distributive property. So we're going to do x squared times 6. That will give us 6x squared. X squared times negative x squared is negative x to the 4th. 2x times 6 is positive 12x, and 2x times negative x squared is negative 2x cubed. All right, so we have no like terms, so we're just going to write it in descending order. So we have negative x to the 4th, and remember descending order means you start with the highest exponent on a variable and you work your way down. So the 4th, then we'll do x cubed, so minus 2x cubed. Then we're going to do the x squared piece, so 6x squared, and then the x piece, which is x to the 1st, goes last. So see that descending order means descending or going down according to the exponent on the variable. There are no like terms here, so this would be the product of f and g of x. Here, again, there are no fractions, there are no square roots, so there are no restrictions on the domain, so the domain is negative infinity to infinity. All right, last but not least, we've got the fraction or the quotient. So we need to find f over g of x, which is the same as f of x over g of x. So f of x goes on top, so that is x squared plus 2x. And then g of x goes on the bottom, and g of x is given by 6 minus x squared. So here what you would want to try to do is try to factor out anything that you can, and then see if you could reduce or cross out anything, any common factors from the top and the bottom. Here there's nothing to reduce. You could factor out an x on the top, but that's not going to be helpful because if you factor out an x on the top, if you factor out an x on the top, you will get x times x plus 2. The bottom does not factor, so nothing will cancel out or reduce. So it's not helpful this time to try to do that. But you should look in case you can reduce. Every time you should always try to reduce. Okay, so there's nothing I could do to reduce this fraction. So this is it. This is your quotient. Now we need to look at the domain. We do have a fraction here, so that is going to introduce a restriction on the domain. Remember to find the restriction on a domain when you're dealing with a fraction. You set the denominator equal to 0, and then you solve to see what restrictions you have. So if I do that, I could add the x squared to both sides. So I'm going to get 6 equals x squared. Okay, you're used to seeing the variable on the left, so I'm just going to rewrite it like that. Now we have a quadratic. We have x squared, so at this point we can take the square root of both sides, put in the plus or minus. So we're going to end up with x equals plus or minus the square root of 6. So we have two restrictions on our domain. The x cannot be square root of 6, and it cannot be negative square root of 6, because both of those, if you plug it into the denominator, will make it 0. So x cannot be those values. So you want to use interval notation to give your domain. So it can be everything except those. So we're going to say negative infinity. The smaller of the two values is negative square root of 6, parentheses, union negative square root of 6 to square root of 6, union square root of 6 to infinity. So remember what we're trying to do is leave out these two excluded values. And to do that, we want to create different intervals, which excludes those. So remember that what we do is we hug the union with the values we want to exclude, and we make sure we use parentheses so that it excludes those values. This says it can be everything except those values. So that is your domain for the quotient. So when you're finding the domain, you're looking for restrictions. The key is you're looking for fractions or square roots. All right, let's look at number 2. So here we're given f and g, and we want to do the same thing as we did for the previous problem. So plus f of x plus g of x. F of x is 3x squared plus g of x is the square root of x minus 5. Okay, so g of x I'm going to do in green again, and f of x I will use blue. All right, so we're adding these two together. 3x squared is not under a radical. X minus 5 is under a radical. There's nothing that I can do here to simplify that. So this is all I can do, is just write it out as a sum. That is the sum of f and x of g. I mean f and g of x, sorry. F and g of x. So now we want to look at the domain. So to do that, I probably should look at the domain of each individual one first. So for f, there are no restrictions on this domain. So it's negative infinity to infinity. G, notice there are going to be restrictions because it's a square root. So to find the restrictions here, remember what you want to do is you want to take what's under the radical, which is the radicand, and say that that has to be greater than or equal to 0. Because remember, you don't want a negative under the radical. So when you do that, you can solve. So we would add 5 to both sides. So we get x has to be greater than or equal to 5. So that means it has to be 5 or bigger. So here the domain is bracket 5 comma infinity. So it can be 5 or anything larger than 5. That domain restriction is going to stay with this part throughout your problems. So here the domain, even though the blue has no restrictions, the green does, and the green exists within the sum. So the domain is going to be 5 to infinity. Okay, so always look at your domains of your individual functions prior to doing the sum, difference, product, and quotient, because that will usually help you when you're doing the domain as you go. All right, let's look at the difference. So f of x is 3x squared minus g of x is the square root of x minus 5. So I need to distribute this negative, although there's really only one thing in the green. It's all under the square root. So that's going to be 3x squared minus the square root of x minus 5. Notice you cannot distribute the negative under the radical. So it does not become negative x plus 5. You can't distribute that under the radical. So it's just a minus the whole radical. There are no like terms. You can't combine something out of the radical with something under the radical. So that is your difference. And again, the g is part of the difference. So the domain, again, is going to be restricted to 5 to infinity. All right, product, f times g. We're going to have 3x squared times square root of x minus 5. Okay, so here, 3x squared is out of the radical, x minus 5 is under the radical. To multiply these, this is understood to be a 1 here. So you're going to multiply outside with outside. So 3x squared times 1 is 3x squared times the square root of x minus 5. You just push them together. That's what a product is. And that's all you can do in this case. So there is your product. Again, the x minus 5, the g of x function, still exists within this product. So again, your domain is restricted to 5 to infinity. Okay, so now let's do the quotient. F of x over g of x. So we are going to write f of x on the top. So 3x squared over g of x is the square root of x minus 5. Okay, now this one is a little tricky when you're finding the domain. So first of all, you cannot do anything to simplify this this fraction. You could rationalize the denominator if you wanted to. I would say that's probably really not necessary to do here. The whole point of this is just to make sure you know how to do your domain. So I would just leave it like that. So on a test, I would accept that as an answer. If you want to technically simplify it all the way, you could rationalize the denominator, but I'm not going to make you do that. I want to know that you know how to write it like this, and I want to know that you know how to define the domain. So here's the tricky part in the domain. You could say, all right, the domain still has G, so it's going to be the same as the others, but it's actually not. So what you really want to do is pay attention to the bottom. In our original domain here, we said that it was okay if x is greater than or equal to 0, right? We said greater than or equal to 0. So this includes 0. But since g is in the denominator, it can't be equal to 0. It has to be strictly greater than 0. So that means the endpoint of 5 won't work, because if you plug in a 5, you're going to get the square root of 5 minus 5, which is the square root of 0, which is 0, and that's not allowed. So you have to exclude the 5. Everything else will work, but not the 5 itself. So when your square root goes in the denominator, you're going to change from a square bracket to a parentheses to exclude the 5. That's the only thing that changes here. Okay? So make sure you keep an eye out for that one. Here is the website for the textbook. If you want to get to that, you can pause here and copy and paste or type it in your browser. Okay, so next, find the indicated function given f of x and g of x. So now we're going to talk about composition of functions. So let me just scroll up a little bit. A composition of functions is folding one function into another. So we're asked to find this. This is the same as this, f of g of x. So we're reading this, f of g of x. These two things mean the same thing. They're just written in a different way, but they both mean a composition of functions. Let me write it like this. Let's say I want to find f of g of x. Notice that what I'm doing is I'm taking the g of x function and plugging it into f. That's what this means. So you're going to take an entire function and plug it in to another function. So you're kind of folding one within another. The order is very important. In this case, it means I'm taking the g and putting it into f. But I could have another variation of this. So I could have g of f of x. And if I use colors to make it more clear what I'm doing, here it would be me taking the f of x function and plugging it into the g. So for these, you always work kind of inside out or backwards, okay? So that being said, let's try some of these. So I think it's easier when it's written like this rather than the f of g, but it doesn't matter. They mean the same thing. If it helps you to rewrite it one way or the other, you can. So this, I'm going to be taking the g and plugging it into the f. So I'm going to be taking g of x and plugging it into f. Okay? So if I do that, I'm going to get x squared, but instead of x, now I have the g function. So it's going to be the square root of x plus 2 squared plus 1. See how this x just got replaced with what's in the box? Okay, and now you're just going to simplify as much as possible. So notice that the square and the square root will undo each other. So we'll have x plus 2 plus 1. Then you can add 2 and 1, and you get x plus 3. So the composition f of g of x is x plus 3. Okay, so now we want to do the same thing for number 4, but notice this is different now. This is g of f of x. So now we're going to be taking f, let me go erase all the red marks up here so I can start over for this one. Okay, we're going to be taking f, which is x squared plus 1, and plugging it into the x in g. So we're taking the f and plugging it into g. So when I do that, I get, let's see, square root, instead of x, I'm going to be putting in x squared plus 1 and then plus 2. Okay, so I can go ahead and combine like terms under the radical. So this would be x squared plus 3. 1 and 2 is 3. Now these are together as one thing, one factor. So I can't just take out the x squared because it's attached to the 3 with a plus. So this is as good as it gets. Okay, so that is my composition if I do it this way, g of f of x. So order makes a big difference when you're doing these compositional functions. All right, number 5, I'm going to have to write down f of x and g of x so I can see it as I move down. So we have to remember f of x is equal to x squared plus 1, and g of x is equal to the square root of x plus 2. Okay, so same directions for these two. So here, notice the difference. We're plugging in a number now. So before we just had x, right? We were finding g of f of x or f of g of x. Now we're finding f of g of 2. On these, it's very helpful to work backwards. So start with the 2 and plug it in g. So you're going to completely ignore f right now. So you're going to start with a 2 and plug it in g. So g of 2 is equal to the square root of 2 plus 2. So I just plugged in 2 for x in the g function right here. That's the square root of 4, which is 2. So 2 is my answer for g of 2. Now what I'm going to do is plug 2 into f. So I used the 2 and the g in the red part. Now I need to use the f with the answer for g of 2. So now I'm going to find f of 2. So my next step is to find f of 2. So I'm going to plug 2 in for the x. So 2 squared plus 1 is equal to 4 plus 1, which is equal to 5. So my answer here is 5. Okay. Now it just so happens that this number, let's see, this number and this number are the same. It does not have to be the same, and it's usually not the same. So just keep in mind that was a coincidence this time. But you're using the answer from the first part in the second part. So let's look at the next one. The next one, I'm going to plug in 0 into f. So that's my first part. Always work backwards on these. So f of 0 is equal to x squared, so 0 squared plus 1. 0 squared is just 0, so this is going to be 1. So the answer to f of 0 is 1. Now I want to use the g. So I'm going to plug the 1 into g. So I'm going to find g of 1. That will be my next part. That'll be the square root of 1 plus 2, which will be the square root of 3. And that's all I can do there. So the answer to this is the square root of 3. So when you're finding compositions of functions and you're finding a value for that, you just work backwards. Okay, so number 7, this again is composition of functions. So we're going to do the same thing we did before. This one might just be a little more complicated because of the fractions. So I wanted to show an example with that. So what we're going to do, and if it helps you to write it this way, you can, f of g of x. So I'm going to be plugging g into f. So I'm going to be plugging g into f, wherever the variable is there. So when I do that, let's see what I get. 1 over, now this x becomes the g function. So 7 over x plus 6 minus 6. Okay, so when I do that, I really don't need those parentheses. So what I'm going to have is 1 over 7 over x plus 6 minus 6. And notice that the 6 and the negative 6 are opposites. So those are going to cancel out. So now I have 1 over 7 over x. And this is just the reciprocal. So this is actually just going to be x over 7. And so that's as far as I can take that one. So that is the composition f of g of x. Okay, so now let's look at the next one. We want to do the same thing, but we want to have g of f of x. So let me write these down really quick so we can reference them. So f of x is equal to 1 over x minus 6, and g of x is equal to 7 over x plus 6. Okay, so I'm going to plug f of x into g. So I'm going to plug f of x into g. So this goes into g. So when I do that, I'm going to have 7 over 1 over x minus 6 plus 6. Okay, so let's look at this fraction first. Here we have the 7 over 1 over x minus 6. Remember, the fraction bar simply means division. So this is the same as 7 divided by 1 over x minus 6. So I can write this as 7 over 1 times x minus 6 over 1. So remember, you can make any whole number a fraction by writing it over 1. To divide fractions, you change to multiplication and you flip the second fraction. So that means that this is actually 7 times x minus 6, which is 7x minus 42. Well, that looks way better than that complex fraction we had to begin with. So I'm going to rewrite the fraction part, right? So this is the same as this. So I'm going to rewrite it like that because it's much easier to use. So 7x minus 42, and then bring down the plus 6. So that's going to be 7x minus, let's see, 36. Okay, and now there's nothing else we can do there. So this is it. This is g of f of x. All right, let's look at the next part. So find the indicated function using the given information. Okay, so this one is a little bit different. This has 3 functions. So we have h of x. H of x is actually the composition. So this is what we get after we do the composition of f and g. So remember, what this means is we took g and we plugged it into f. So we took g and we plugged it into something in order to get x plus 3 squared. So what could f be in order to make it look like x plus 3 squared? Well, we plugged in x plus 3. Everywhere we plugged in x plus 3, that becomes an x. So that becomes x. So we're substituting x plus 3 for x. So that red x is what should be for f. So f of x should be x squared. So you're simply going to replace whatever this is in h with an x. So I just replaced it with an x. And then that's what your other function is, should be. So x squared. Okay? The next part is we're going to use graphs to evaluate the expressions. So we're going to use the values on the graphs in order to do compositions. We're going to work backwards. So this isn't as bad as it seems, okay? First of all, notice that I have F and I have G, and it's labeled in the graph. So this is F, this is G, the first graph is F, the second graph is G. Okay, so now notice what I want to do here at number 10. Remember, you work backwards. First, I want to find G of 3. Remember, 3 is the X value. So I'm going to go over to the G graph, which is the second graph. 3 is my X value, so right here. I'm going to find my corresponding Y value, which is 4. So the answer to this part is 4. Now I'm going to use that, and I'm going to find F of 4. So now I have to use the F graph, and 4 is my X value. And so here is the point, so that is a Y value of 0. So the answer is 0. Okay, we're going to do a couple more to make sure you got this concept. So let me erase the markings on the graphs, and let's try the next one. Okay, so the next one. First, we're going to find 1 with the F, so F of 1. So we're going to go to the F graph, and we're going to find X is 1. We're going to find the corresponding Y value, which is 3. So this is 3. Then we do the next part. We're going to find G of 3. So we're going to use this 3 and plug it in for X in the G function. So we're going to go to the G graph. 3 is the X value. I have to find the corresponding Y value, so the answer is 4. Okay? So just work backwards, and you're going to use the graphs to figure out what numbers you'll be getting for these. They're giving you the X value, you find it on the graph, find the corresponding Y value, and that's it. So let's look at number 12. Let's see, I also have 13. So let me write 13 up here. Let's see, I'm going to write 12 and 13 up here so that I don't have to scroll up and down. So 12 is F of 1, and 13 is G of 2. Okay. So this really is just trying to show you that you don't have to necessarily combine or compose two different functions. So for number 12, you're going to use the F function twice. So the first thing you're going to do is find F of 1. So you're going to go to the F graph, the X is 1. You're going to find the corresponding Y value, that's 3. So this is 3. And now we have another F. So we're going to have F of 3. So I'm going to go back to the F graph, find 3 on the X axis, find the corresponding Y value, which is 2. So the answer is 2. Okay? Let's do the next one. So this one, instead of using F twice, I'm going to be using the G twice. So I have G of 2. So I go to the X axis and find 2. The corresponding Y value is 0. And now I'm going to use that, G of 0. So 0, I'm going to go up to the graph and see that that is a 2. So my answer here is 2. So you just keep working backwards until you get to the very front. So this could have multiple F's, right? I could have asked you to find F of G of 0. Now that's a little ridiculous, and we're not going to do that many. But my point is, you could find G of 0, you find that answer, then you find F of that number, you find that answer, you find F of that number, you find that answer, you find F of that number, and then you have your answer. So it doesn't matter how long it is. The process is the same. You just keep working backwards until you get to the very beginning, and then you'll be done. All right. All right, the next one is, it's the same thing as the graph. It's just using a table of values instead, but it's the same idea. Let's see if we're going to be able to fit all these on here. Yeah, we kind of can. All right, I'm going to go ahead and write the 17 up here, just so I don't have to scroll anymore. G of 0. Okay. Now it all fits nicely. So here we're going to do the same thing. First thing we want to do is note that we want to find G of 1. So 1 is the x value. So you're going to go to the x column, right? The x column, and find the 1. And then you want to go G of 1. So we're going to go over to the G column, and we see that that is 0. So it's 0. Now we want to find f of 0. So now our x is 0, and we want to go to the f column. So that is 5. So our answer would be 5. So you always start with the x column, you go over to the f or g depending on what you're finding, and continue from there. Okay, so let's try it again. So I would encourage you to pause the video, try to find these next 3 yourself, and then come back and see if you got them right. Okay? So now we're going to do the next one. The first thing we're going to start with is the 2. So we want to find f of 2. So 2 is our x value, and we're looking for f of 2, so we're going to go to the f column, and we find that that's a 1. Now we're going to do the same thing for g of 1. So 1 is our x. This time we're using the g column, so we see that that's a 0. So our answer is 0. All right, number 16. We have -2. We want to find g of -2. Oops, let me go back and erase all the stuff on the chart. Okay. So g of -2. -2 is our x value. We go over to g column, we see that's -3. And now we're going to find f of -3. So -3 is now our x. And we're going to go to the f column, and we see that that's 11. So our answer is 11. All right, the last one. The last one we have is g of 0. G of 0. So 0. So g of 0, we're going to go to the x column and find 0. We're looking for g, so that'll be a 1. And now we want to do the same thing for g of 1. So we're going to go to 1 in the x column, the g column, that corresponds to a 0. So the answer is 0.